The type of question you might see for this section is as follows: which of these shapes has two acute angles and one line of symmetry? So I'm going to deal with each shape individually and look at this one. Now this shape has two angles that are acute and two that are obtuse, so it satisfies the first part of the question, but does it actually satisfy the rest of the question? So what I suggest to the students is to rotate the shape so that whatever line they think is the line of symmetry is vertical. We seem to see this better. I think that's vertical there. So now I'll take a straight edge, a line, and go across. So there's my line of symmetry. Not perfect. And I'm going to start that over. Here's my line of symmetry. Now I'll take the shape and rotate it so it's lined up a little better. There it is. Got my line of symmetry. Now, this one's close, but if you look, this angle is actually higher than this one. So if I draw a horizontal line across, you will see that they do not match. So this does not have a line of symmetry. That is not a line of symmetry. And if I take the shape, move it elsewhere, rotate it, there isn't another possible line of symmetry. Some students think that a line like this is a line of symmetry, albeit a little bit lower, like that. But again, if we rotate the shape, as I always ask students to do, and then put that same line there, I think I'll just delete the line, make a new one, you can see that this is higher than this point, so it does not have a line of symmetry. So this shape is not part of the two acute angles and one line of symmetry. That, by the way, is a parallelogram. Here is a trapezoid, and if I look, there's 1, 2 acute angles there, and 2 obtuse, so it satisfies the first part, but does it have one line of symmetry? Well, I see what I think is one, approximately here, and that looks good, but is there another? Because if it has two lines of symmetry, then it doesn't satisfy the question either. I'm going to get rid of that line and rotate the shape. Doesn't look symmetrical on either side there. Upside down is the same. That can't be a line of symmetry. So this one does satisfy both parts of the question. I'm going to put it underneath to say that it does. Here is a rectangle, and if we take our line, you notice that it has one line of symmetry here and another one here. Also, it has right angles, which are not considered acute, so this does not satisfy the question. So I'm going to move it over here into the no pile. This one's a little trickier to see. I am going to rotate it as I've suggested, and it does actually look like there might be a line of symmetry here and here. So let's take our line, go from top to bottom, and that does look like it will be symmetrical. We can check like that. So there's actually two lines of symmetry here. This is a rhombus. It's hard to see that, but this length is the same as this length. And so while it has lines of symmetry and two acute angles, it has too many lines of symmetry, so we cannot include that one. Move it over into the no pile. And then we've got our square. It has actually lots of lines of symmetry. One here, one here, one this way, roughly, and one this way, roughly. So that clearly doesn't satisfy it. Plus it has the right angles, so that cannot fit into our category. So the only shape out of those five that has two acute angles and one line of symmetry is the trapezoid.